In this lesson, we're going to simplify and evaluate expressions. Now, the first thing to realize, there is a difference between expressions and equations. An expression is not going to have an equal to sign. So if it's got a variable in it, you're not going to be able to find the value of the variable. So say, for example, you will not have an answer where you're going to say x is equal to or anything like that. That is not going to be possible. All you can do is simplify it. And there are things we will do to simplifying. We'll be combining like terms. We could use a distributive properties to help us, or we could divide any particular term by 1. Let's say if I wanted to, and I had the number 3, I could multiply 3 by 2 over 2, and that would give me 6 halves. It's the same thing, same value, but it's written differently. So I can multiply each term by 1. And of course, I may be using order of operations in there also, because you would use order of operations, not reverse. We would use order of operations to simplify an expression. So let's go ahead and take a look at these. What we have here is we have an expression that has some x squareds and x's, and when we are simplifying an expression, we can only combine those terms that have exactly the same variables with the same exponent. So this x term that has an x in it is not going to be able to combine with the term here that has an x squared, because the exponents on the x's in those two terms are the same. Also, if I would have, say, some term that would be at the end of this, say it would be plus 5xy, of course that's not part of the problem, but if it was, that wouldn't combine with any term, because each of these terms, this term has x squared, this term has x. Notice that none of them have a y, so that wouldn't combine with any of those. So for this particular problem, the 7x squared and the minus x squared can combine. Let's subtract the coefficients. 7, there's a 1 in front of the x squared in this case, so we would have 6x squared. Now let's look at the x's. This is a 12x, and it's a subtract 4x, so we could say 12 minus 40, and that would be 28, minus 28 actually, so minus 28x, and that would be my simplified expression. That's as much as I can do. Let's go down to some that's got the distributive property. And then the way we use a distributive property is everything in the parentheses, in this case, because this will be a multiplication right there, is everything in the parentheses will multiply by 5. So we would have 5 times n squared. Now we have a plus, so it would be plus 5 times the n. For the other side, this n squared and this, now this is a subtraction, so it's really a minus 3 times n squared. So we could say that's a minus 3n squared. And this minus 2n part right here is going to have to multiply by the minus 3. So that would be plus a minus times a minus is plus 6n. Now let's combine like terms. So we have the 5 on the n squared in the front and a minus 3 on this n squared. So 5 minus 3 is 2. And we have 5n and a plus 6n. And that's my answer to that one. For this kind of a problem, I'm going to go ahead and do what is in the parentheses first. So I'm going to have 3 times x. That will give me 3x plus 12 over 2 minus 6 plus 2x all over 3. Well, I cannot subtract those currently because they have different denominators. So to get them to have the same denominator, which would be a 6, I'm going to take the first term, and I'm going to want to get this 2 to be a 6 in the denominator. So of course that would multiply by a 3. So the whole term would have to multiply by 3 all over 3. That would give me 6 in the denominator of the first term. Now the second term, I have a 3 in the denominator. I want to make it a 6, so that whole side is going to have to multiply times a 2 over 2, right? I'm multiplying by 1, so I'm not really changing the value of the term. All right, so let's go ahead and do that multiplication. I'm going to have this 3 times 3x, that would be 9x. 3 times 12 is 36 over 6. Minus this 2 will multiply by the 12. By the 6, give me 12s. And 2 times 2 is plus 4x over 6. Now is where we have to be careful, because I am subtracting basically this whole term. So because this whole term is subtracted, when I combine them, I have to distribute this subtraction to both of the numerators. So I would have 9x plus 36, subtract the 12. Subtract the 4x. And all that would be over the common denominator of 6. Now let's combine. So on my x's, I have 9x minus 4. It's 5x. And I have 36 minus 12. That would be 24. And that could be my final answer. Another way that I could express it if I wanted to be 5x all over 6 plus 24 over 6. Which would be the same as 5x all over 6 plus 4. Now, to me, this is probably the simplest looking form and the way you'd want to leave it. Now, the next, we're doing some evaluations where I have to substitute values into an expression. So I have 9x plus 8y, and it says evaluate that when x is 4 and y is 5. So I'm going to plug x equal to 4 into my expression, and y equals 5. So that would be 36 plus 40, 76. Okay, the last one is to evaluate 2x plus y, and it gives me the values for x and y here. So we're going to say 2 times 10 plus the y value, which is 6, all over 3 times y, and y is 6, plus x, x is 10. Doing order of operations, 2 times 10 is 20, plus 6. 3 times 6 is 18, plus 10. 26, all over 18. So we need to reduce that fraction. So if I divide both the numerator and the denominator by 2, I'm going to get 13 all over 9, and that's simplified, and I'm just going to leave it in a mixed number. Okay, here's a few more things to think about. Is if I have a negative and it's in front of a number or a variable, it is not going to get the power that's on that expression unless it's in parentheses. So for example, on this problem here, this says to take 2 to the 4th power first, because we do exponents before we do any sort of addition or subtraction. So 2 to the 4th power is 16, then I add the negative. This is a negative 16. Now this one is a little different. It has the negative 2 to the 4th power. So we're actually going to be taking a negative 2 times a negative 2 times a negative 2 times a negative 2. So you can see that if I multiply all those negatives together, it's going to be a positive, and the answer to this problem will be a positive 16, because the negative is actually involved in taking it to the 4th power. For this one, I'm going to do the cubing first. Notice there's no parentheses around the 2 is not, the negative and the 2 are not combined, so this would be 2 cubed, that's 8, and then I would take the negative on the 8, so this answer would be negative 8. And for this one, now I will actually cube the negative 2. So this would be a negative 2 times a negative 2 times a negative 2. Negative times a negative times a negative gives me a negative number, 3 negatives, and that also would be a negative 8. This one here, we're going to square the 1, that's 1, then put the negative on it. On this one, the negative 1 is actually squared. Negative 1 times negative 1 gives me a positive 1. This would be a negative 1 times a negative 1 times negative 1. 3 negatives, that'd be a negative 1. And this one is exactly the same as the other one that's written there, so I guess I must have wanted it to look more like this. So we're going to take 1 cubed, that's 1, then put the negative on it, I get a negative 1.